Hello guys, now we shall derive the expression of height of a liquid in a capillary tube, or we can say the rise of liquid in a capillary tube, which is called ASCENT formula. Okay, so this is under surface tension. Hey, surface tension noyami ania can treat an surface tension at chuan beaker amo noa amo tuya oma the chuan straw amo pipe te fine bore capillary tube kha kan da chuan tui kha alo chhothin ti kha kan thria kha eng tiang sang nge alo chhothin ti kha a height kha tuna chuan a formula ha kan derive chho tur khania. So when we dip a pipe or a capillary tube into water in a trough or in a jar, so we know that in this capillary tube the water will rise a bit higher than the level of the water in a trough, isn't it? That we have already learned before. So how much height will a water rise into the tube? Okay, so we are going to derive the formula of height h. Okay, h. So first of all, let me draw a capillary tube. Okay, this will be a trough. Okay, first a container, so that there is water, and also let us draw a pipe. Okay, pipe. Think that this is a very thin pipe terutenia. This is water, so it will rise up to a higher level. Okay, so now we see that when the water rises, it gets stick to the wall, or it wets the wall of the container, okay, of the tube. This is a very fine tube. It will look like this. This is called the meniscus. Okay, meniscus. And we shall draw like this, like a circle. This is a round. This is a meniscus, and there will be, so this is due to surface tension of the liquid. Force T. Okay, T will act, and force T per unit length acts along the tangent to the meniscus. Let us draw like this. Okay, like this. This is T. Okay, what is T? This is a force per unit length, or it's simply called tension. Okay, tension. We draw tangent to this meniscus. Okay, so there will be an angle theta, some angle. This is an acute angle. Okay, acute angle. You shall know that it is acute angle less than 90 degree, 0 to 90 degree. Okay, and so what thing happens? You will draw T, then you must know that the reaction equal to T at its point along the circle, okay, of contact. There is also a reaction. Okay, so the opposite force according to Newton's laws of third laws of motion, the tube gives an equal and opposite reaction, which is called R, which is same value of T. Okay, and also here we have theta, so same value of T. This is the force per unit length, and it's have a reaction same value as T, and this is the meniscus, and where the circumference of this meniscus is equal to 2 pi r. Okay, 2 pi r circumference. So we are going to find out what is the height formula. Okay, now this reaction R at its point along the circle of contact can be resolved into two components. So it is like the first component this way we shall draw like this. This is the first component. It is d sine theta. Okay, d sine theta. And the other component, so you must know that this sine theta unit sine theta per unit length along horizontal and radially outward. It is outward. Okay, so horizontal and outward. And also one component, another component we have to draw here. There is a reaction component of this reaction R, which is t cos theta per unit length along vertical in upward direction. Okay, upward direction, you must know that. So we resolve into two components. We can write like this here. These two component, one is t sine theta, okay, per unit length. Another one is t cos theta per unit length along vertical in upward direction. Okay, so now the total, what will be the total upward force? Total upward force. The total upward force on the liquid, is equal to circumference of the meniscus all throughout the tube into this, the second component, the upward component, the t cos theta. Okay, this is the total force, 2 pi r into t cos theta. Okay, this is, so we can write, this will be the, okay, equation. Let's say this equation number 1. Okay, this is equation number 1. Okay, and next, so we want, so under the effect of, we have to know that under the effect of this upward force, the liquid rises in the tube to a height h, say, let's say this h, small h, till the weight of this liquid above the free surface, this is the free surface, above the free surface become just equal to the vertical upward force. Hemi vertical upward force in tuikha ti chhota mo h thlengkha ichuan masala a chhozela ichuan a rina a weight ne na in book a force kind book tok che chun a ding don ta ni mo kan thita a in balance don ti na ni chu mo chu wang chun ti hian kan zek thei ta ni. So it is balance, weight of the liquid above free surface of liquid in the container. So my handwriting is very bad, but don't worry, you can learn it very well. So weight of the liquid above the free surface is equal to volume of liquid in the tube up to height h plus volume of liquid, I write in shortcut, in meniscus. Okay, meniscus le volume of liquid in tube, hemitube mi zong tui le helai meniscus hemi chin hey, so a khwar ve do hemi tui le hemi pumpui bel khom hi to the weight of the liquid above the free surface and look chet tina ni tani. So we have plus here. So also we can split again the volume of the liquid in the tube up to height h plus volume of the liquid in meniscus is, what is volume of the liquid in meniscus? It is the volume of the liquid in cylinder up to the radius. This is up to this much plus up to this. How can we calculate? So volume of liquid in cylinder or radius r and height hr minus the volume of hemisphere of radius. Okay, hemisphere hey kan pai don tani achan chui lai tu yum ve ve klawa helai te chau ani wangin lai te chau kha le helai he chu cylinder volume of cylinder formula kan apply thea ma se helai ka chu apply ve thei thalo ta ti chon a sphere ang khan mo alom ta hemisphere ani ta ni he sphere ni lawa hemisphere lai tu te le helai tu bel common chu so we can write so I shall write it directly. So this is the pi r square into h is the volume of a liquid in a cylinder of radius r and height h, plus this is the volume of liquid in cylinder of radius r and height h, pi r square. Okay, pi r square. This one is this total, this volume liquid, in pi r square will be this whole volume, but we have to minus this part because it is like this. Sorry, we have to write like this up to this much. This is only water part, not the whole, so we have to minus this hemisphere. Then from here, pi r square minus into here we have to write r radius minus 2 by 3 is the formula of hemisphere, volume of liquid in a hemisphere, 2 by 3 pi r cube. Okay, and this will be, we have to multiply here also. I miss one thing, in this whole thing we have to multiply with density rho into acceleration due to gravity g. Okay, acceleration due to gravity g. So this is pi r square into h plus pi r square into the radius minus volume of a hemisphere, 2 by 3 pi r cube into density into g, acceleration due to gravity. Okay, so let me continue. So if we solve further, it will become like this: h plus r by 3 rho g. Okay, rho g. So this is equation number 2. Let's say equation number 2. So weight of the liquid above the free surface of a liquid in the container means this weight, whole weight is equals to pi r cube h plus r by 3 rho into g. Okay, so we know that equation number 2. So the total upward force for equilibrium, in equilibrium, total upward force is equal to weight of liquid above the free surface. Okay, therefore we know that the force that we have taken in the first equation, so equation 1 will be equal to equation 2, so that the liquid will rise no more and it will be balanced. The weight and the force will be balanced. Okay, this one in tukta alo ding ta atui kha total force kha ma han ji to 2 pi r into t cos theta equal to pi r square h plus r by 3 rho g contain it. So if we solve further, it will comes out tension T r h plus r by 3 rho g 2 cos theta. Okay, 2 cos theta. So equation number 3. So it comes out tension, formula of tension per unit length comes out like this. But we have to know that since r by 3 is very less as compared to h height, so we can neglecting Okay, cancelling this r by g in this one. So we have t equal to 8r rho g divided by 2 cos theta. Okay, 2 cos theta. So we have this t equals to r rho g divided by 2 cos theta. So now you will take out this h, then this will goes up, so we have it will be 2t here cos theta, and what will be the denominator? R rho g. Okay, R rho g. So we have h, height of a liquid. So the formula of height h of a liquid, so this h formula is it equals to 2t cos theta divided by r rho g. So this we have rho, where we have to know that this is the tension and this is the angle theta, and r is the radius of the tube, and this is the density of the liquid, and g is the acceleration due to gravity. So this expression is called ASCENT formula. Okay, ASCENT, ASCENT, ASCENT formula. Okay, so now we have derived the ASCENT formula, or we can say the height of the liquid in a capillary tube, h equal to 2t cos theta divided by r rho g. So it is very, very simple. Okay, that is all about ASCENT formula under surface tension.